Artificial intelligence for project managers. Are you ready? Today's topic. Hi, I'm Joshua Barnes, and I'm joined once again by Scott Ambler. Scott's been on a lot of live streams that have focused on Discipline Agile. So for those of you that aren't aware or even don't know who Scott Ambler is, not only is Scott a co-creator of Discipline Agile, but Scott's got a tremendous background in both being a consulting methodologist as well as an Agile data coach. You've authored what, close to 30 books, I think? Over 30 books, just around 30?
I think it's 30. It's hard.
30 books.
Hard to say.
That's a lot of books. And Scott is currently in a master's program for artificial intelligence.
Yeah.
So I'll let Scott get going with his presentation in just a minute. But before he gets going, I also want to mention, let me get to the comments area. And what I'm going to do is Scott has a new workshop for Agile data warehousing. And Scott, if you want to just also give just a tiny little bit of tidbit on that before we get into today's topic.
Yeah, it's a 2-day workshop delivered live. And as the title says, it focuses on how do you take an Agile and probably more accurately, lean approach to data warehousing. So it's easier said than done. So, which is why it's 2 days.
And I see a few comments. Yeah, so definitely post where you're from. And yeah, 30 books, exclamation point, probably about 5 exclamation points. But yeah, so let's get on with today's topic. And let me go ahead, and Scott's got some materials that he's going to take us through. And then, yeah, definitely post from where you're at. And also any questions that you've gotten at the end, we'll have Scott cover questions. Take it away, Scott.
So I'll leave the questions to the end, but please put them in the chat as we go along. And if it ends up that we run out of time, then I'm more than happy to write a blog or something to answer any questions we didn't get to. So anyway, so today what I'd like to do is walk through artificial intelligence for project managers. And this is from the point of view of what if you're on a team developing an AI, particularly via machine learning, which is probably 90 to 95% of what you're going to be doing in corporate America. So it's not, this is not, AI, how do PMs apply AI in their day-to-day job? That's the easy stuff, which is all important, but that's not what this is. So we're going to dive into the harder stuff. What if you actually got to build this AI, these AI things? So as you heard, I'm, one of the co-creators along with Mark Lyons of the DA Toolkit. I'm also the thought leader behind the Agile data and the Agile modeling method. So we'll hear some ideas from those two methodologies here as well as from Discipline Agile. So what I want to do is give a very brief overview of what AI is and where it's going, and more importantly, ask the question: are you ready? Is your organization actually ready for this? And chances are pretty good the answer is no, but that's okay. You can get ready. Then I'll walk through what the life cycle looks like for AI, particularly for machine learning. And I'll actually present several versions of it because there's not a consensus right now of what this looks like. There's a lot of great material out there, but we haven't sort of formalized it yet, at least in my mind. I'll talk about data quality a little bit as well. This is where usually the showstopper for most organizations. And I'll get into some ethics and business implications for you and end up with success and failure factors. It's interesting. There aren't exact figures right now, but the AI endeavors or AI projects run about an 80% failure rate at the present moment. So chances are pretty good. It's harder than you might think. So anyway, let's get into it. So what is and what isn't AI? So first of all, it's software. It's not magic. And although there's some magical things happening in the background that we're not quite sure what's happening, but that's okay. And as Josh said, I'm a good part of the way through working on a master's degree right now in AI, and I'll finish it up at the end of this year. But learning a lot of great stuff, and frankly, just scratching the surface when it gets down to it. So beware. It's one of the challenges I think with AI right now is it's going to be very difficult to find AI experienced people. A lot of people claiming, they've got more experience than they do, but this is a very hard and difficult topic, which takes many, many, many years to really master. So just some definitions. So first of all, like this, start AI is a very big topic. I'm going to focus on the machine learning aspects of it. But first, deep learning is one flavor of AI where we consider AIs or computer systems to be brain-like, to have be based on artificial neural networks, ANNs. And machine learning is the training of these neural networks without explicit programming. So you've probably heard of large language models like ChatGPT, where there's they train on the internet, on all the data out there on the internet, for example, and they learn from that. And yes, humans are involved, but for the most part, it's the algorithm learns itself, and the model is trained itself with some help by the humans as needed. And then and machine learning is going to be the focus of what I'm talking about today. And then finally, we have artificial intelligence, which are computer systems that appear to perform tasks that would require human intelligence. So let's dig into that a bit. So there's three levels of artificial intelligence. The level that we're actually at is generally called artificial narrow intelligence. And it's AIs that are trained for specific tasks, such as, for example, examining the MRI scans and looking for unfortunate growths and things like that. So very narrow AIs. ChatGPT is a fairly narrow AI as well. It's this human interaction via chat type of a thing. The next level, which is what everybody's afraid of, and not quite Terminator level stuff yet, but is artificial general intelligence. And this is basically where the AI is as good or better at intelligence tasks than humans are. So the Annie's artificial narrow intelligence are good at a specific task and can generally beat the humans at that task. AGI, which is we're not really there yet. We're talking about it. We're working on it, and we may see that this decade, maybe not. There's great debates over when we'll see it. If we'll see it, I suspect we will, but we're not there yet, without a doubt. So AGI is, the AIs are better at a lot of things. And then artificial superintelligence, which I highly suspect will come very quickly after we reach AGI, is when the AIs are significantly better at pretty much everything. And we're really hosed at that point. And so people are generally phenomenally afraid of this, and rightfully so. And we'll have to see how this one plays out. But if you've been following this at all, there's a lot of discussion in the community about this and a range of opinions. But better to be safe than sorry, I think, on this one. So, anyways, we'll have to see how it plays out. For the normal human beings like us, this is completely out of our control, like it or not. So we're going to have to trust the tech bros a lot, which is unfortunate. So, are you ready for AI? That's, I think, a very valid question, and chances are pretty good that you're not. For several reasons. So this list of 6 questions, and I'll give you a chance to look it over. Basically, you need to answer yes or we're almost there for all of them, or you're simply not ready. And that doesn't mean you can't get ready, but it just means that you're not ready yet. And this is a challenge because a lot of organizations are jumping into AI and trying to apply AI, particularly machine learning, and running into problems. This is why we're experiencing a fairly low success rate. And one of the big challenges is the data debt, the poor quality data. And you hear a lot of complaining about this, and rightfully so. And I think what's happened is organizations have been allowing data technical debt, this poor quality data, to build up over time. And or sometimes over decades, depending on how long your organization has been in operations. And now it's really sort of caught up to us. And for organizations that have been trying to do data warehousing effectively, who have been trying to do data-driven decision-making and all that sort of stuff the last 2 years, they've probably run into these data quality problems as well. We're guaranteed to have run into these data quality problems as well. So the organizations that have truly been trying to do data-driven stuff are probably further ahead than the organizations that haven't. But either one of those categories of endeavors, either trying to become more data-driven or be trying to apply AI in organizations, you will run aground on the data quality problem, and you need to fix it. And what's interesting, and perhaps unfortunate, in many cases, the data quality problems are the result of an on-time, on-budget mentality on many of the IT projects we've had in the past. Now, it would be easy to blame the project managers for this, and certainly some of the blame should land there. But a lot of it is also, most of it should be put on our business leaders, because they've motivated the PMs to do questionable things, which then force the teams to do questionable things. And almost always, if you're an IT person and you're forced into this, on time, on budget, or reasonably close to being on time and on budget mentality, then quality gets cut. But that's just the way it is. And this is normal human behavior, unfortunately. And so the quality gets kicked down the road. So now this is all added up. So now it's time to pay the data quality piper, because you simply can't move forward now with this poor quality data. So you're going to have to address it somehow. So keep that in mind when we start. We'll hit it in a few slides. It's the short story. So how does a machine learning endeavor or project actually work in practice? And so I want to make 4 uncomfortable observations, at least potentially uncomfortable observations, and then a radical claim. And I'm going to completely and utterly justify this radical in air quotes claim. So first of all, machine learning endeavors are not projects. And frankly, trying to take a project-driven approach to this, unless it's a pilot project where you truly intend to throw it away, is pretty much the kiss of death. So because these AIs, if you're successful, will last for a long, long time and will need to be retrained. And so it's not a project. It's really a product type of an approach. And yes, a series of projects might work, but the overhead and risk that you inject by doing that is incredible. So I would highly suggest not doing that. So anyways, we'll look at what the life cycle looks like, and then you'll see why it's not a project. A predictive approach, the old school thinking, has exactly 0 chance of success. Now, I'm a firm believer in a hybrid approach, which is what we'll see in a second, but a pure predictive approach will not work. No way. A pure agile approach has very little chance of success. So, you've got all these Scrum or SAFe people, quickly jumping on the AI bandwagon. Be very careful, because we'll see as well that that doesn't really work as well as they like to claim. But better chance than predictive. So, give them that. A pure lean approach has a much better chance, but still isn't ideal. And what you really need is a disciplined hybrid strategy. And that's what's going to work out. So what does that look like? So when you start reading the literature, it's interesting. Oh, fantastic material. Don't get me wrong here, but they don't really talk about life cycles all that much. It's all very techie, very detailed, very techie. Here's what we do. And so the story at a high level is, well, we train the AI, we build this AI, we train it, and then we put it up there in the wild. It runs. We make inferences. It predict. They're prediction engines, right? They make predictions based on the input that they're getting, and then we have learnings coming back, and we retrain the AI based on what we learn. Now, sometimes this training is very continuous. Right. So we're seeing chatbots, for example, that get feedback from the interactions that they're doing and pretty much improving in real time what they're doing. In other cases, we see AIs that may be, like a fraud detection AI at an insurance company, and they'll be retrained on a quarterly basis because that makes sense in that environment. So this is where the project approach starts to fall apart. When you're constantly retraining, constantly improving, then it's not really a project anymore. It's really this continuous delivery type of an approach. So anyways, this is a very high level view of the universe. A more detailed approach would start to look something like this. And this is, I'm building up to the answer. This is not the answer either. But so what happens during construction is the question. Well, we've got to choose a training strategy. And that means, we got to choose an algorithm, because there's many algorithms, right? You could do ANNs or CNNs or random forests or decision trees, or there's many options. So you've got to sort of choose the right, what you believe to be the right algorithm for your environment, for the problem domain that you're trying to solve, and then train that model. And you might guess wrong, right? So this is and so you've got to go back and guess again. Or you might have multiple guesses, and maybe it's this, maybe it's that. So you train multiple models using different algorithms, and then you compare and contrast, and then you choose the best answer, or you combine answers. This is called an ensemble. So you got to choose a training strategy. You've got to do data prep. So if you talk to data scientists who are key players on your team, the classic joke is that data scientists spend 80% of their time cleaning data, and the other 10% or the other 20% of their time complaining about cleaning data. And it's not far off, actually. A little extreme, but it's not that far off in practice. So this is a problem. We'll talk about that in a bit. So you got to train the model. You've got to test. You got to validate the model. How well are these predictions actually occurring? How good are these inferences that we're making? And then, assuming that it works, things work out, then you deploy the AI. And then finally, it's up and running in production, and you're making inferences. So this like the way I've drawn this here, it almost looks like it's a predictive life cycle. But, reality comes into play, and it's not, because what we find is that, we have to, as we're preparing the data, we'll do some data prep. We train, we have to prep more data. We start getting feedback from our stakeholders, our requirements evolve. We start discovering that the data is not quite what we thought it was going to be, and what we thought we could do, we can't, but maybe we can do this. So things change. We also may discover that we guessed wrong, and that whatever algorithm or algorithms we chose to work with to begin with, we made the wrong choice. We made a good choice to begin with, but it just didn't play out. So now we got to make another choice and try again. So anyways, this is a very iterative aspect of construction. Deployment, as well as more, is, depending on how skilled you are, is either a small phase, or it's hopefully a fully automated activity. When you're taking a full, ML ops or DevOps type of an approach. But deployment is worth calling out on its own, because this is a very big issue. So, where are you deploying to? Are you deploying something that's going to run on the cloud? Are you deploying something that's going to run on an edge device, such as a phone, or a combination thereof? Or what type of edge devices are you deploying to things that are sensors? Are you deploying to sensors, a little bit some smarts in the sensor, and then you got something that's going to cloud. So there's many deployment choices that you can make. They're all good. They might evolve over time. So you need to think this through, and you better automate all of this, is the short story on that one. So anyways, as I said, I'm a firm believer in calling that out, because there is some very interesting complexity there. And from a project management point, or from a management point of view, I should say, there's some interesting risks that you want to address. The other issue is, this is also not, this previous version of lifecycle was also not accurate, because there's some initial envisioning going that has to occur should occur at the very beginning. So what is the actual usage of this thing that we're building? How are we going to use it, and why are we building it? What data do we have? What's the level of the data quality? Is this viable? When there's an 80% chance of failure, you would darn well better be asking, is this viable, on a very regular basis? Because the chances are the answer is no. So I want to pull the plug as soon as I can, or pivot and get going in the right direction as soon as I can. So we better darn well be doing reality checks all the way through, particularly at the very beginning, because chances are pretty good at the very beginning you had a really bad idea and you should abandon it. So, and almost always it'll be the quality, the quality of the data will drive that. I've been involved in several efforts now with various organizations where they thought that, they'd hoped they had a 6-month, machine learning pilot project on their hands where they're going to learn and build something cool. And then they quickly discovered they had a multi-year data quality problem on their hands that they really need to address probably now. So anyways, stuff happens. So do a reality check is what I'm saying. So anyways, this is more of a classic project, agile project lifecycle type of a view. But let's, there's other ways to look at this. So you've probably seen something like this, like a DevOps or an ML, machine learning ops type of a life cycle. So I've just mapped the activities on the previous slide to the classic infinite loop, Mobius loop diagramming going on here. So if you prefer that sort of life cycle, that's great. If you're familiar with CRISP DM from the data mining community, and this is more of a European standard actually, and this is the CRISP DM rendering of the machine learning lifecycle. So not totally accurate. Now Microsoft actually has a nice version of this lifecycle which shows where stakeholders get involved. So slightly better graphics than what I'm showing here. So the point is the life cycles are all communicating the same sort of thing, but in different ways. So whatever rendering you like, focus on that. Having said that, I do find this, the stage or the phase-based approach to be good, particularly. So this slide is looking at common life cycle risks. And for those of you familiar with DA, I'm using slightly different terminology. So envision would line up reasonably well, does line up reasonably well with inception, construction, deploy, transition, and then make inferences as production phase. The fact is envision is a more common term in the AI community than that inception, and deploy is more common than transition. So I'm trying to use terminology that you're going to run into in the literature. So anyways, speaking about the literature, you're often not going to see this sort of information called out well, or you'll see it spread out everywhere is what the real issue is. Nobody really gathers this. So what are some of the life cycles, or what are some of the risks that you're going to run into throughout the life cycle? Well, at the very beginning, when you're doing envisioning, just things like misaligned stakeholders, poor quality data. So having adequate data, that's probably a given. Biased data, that's exactly 100% chance you're going to run into that. All your production data is biased in some way. Whether you know that or not is an issue. Whether you can reduce the bias is probably also an issue as well. You'll never get rid of the bias because the data reflects your current business processes. Your current business processes reflect the people that perform them. The people that perform them are human and as a result are biased. So you've got biased people working biased processes, creating biased data. So it is what it is. But what you need to do is start, building, you need to build a diverse cross-discipline team who have so the more diversity you've got in your team, the greater the chance of you being able to detect the bias that's in your data. Whether you can do something about the bias is another story, but if you can't detect it, you're not going to be able to deal with it. Or what'll happen is you will detect it once it's up and running in production when you've potentially caused significant damage. And of course, as I was ranting earlier, you want to consider the viability of what you're doing. Another two common risks are you do insufficient exploration up front. So you've got the agile purists going rah, 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 big modeling up front, big design up front. That's evil. Just jump in and start coding. That is foolish. Or you've got on the other end of the spectrum, you've got the traditionalists that want to do far too much modeling and far too much exploration at the beginning. Or you've got, unfortunately, you've let the designers get out of control, and you've got what I call detached exploration, where they might be off exploring and trying to create this, envisioning this perfect solution, and they're trying to win an award or something, or a pat in the back by somebody, and they're not really dealing with reality, right? They're not jumping into the actual how are we going to build, like asking questions like how are we going to build this. Absolutely critical. So the people doing the envisioning had darn well better have construction skills and understand how they're going to do this. Otherwise, Be very, very careful. They're probably going to do more damage than they will good. And then during construction, you'll run into data problems, guaranteed. And so during envisioning, a question you should be asking is, what's the level of data quality? What are we going to do about this? And then during construction, as you realize, oh my God, it's worse than we thought. I've never run into a situation where that wasn't true. So maybe one day we'll get it right up front. But usually once you start digging, it's just even worse. And that's okay. It is what it is. So, but you got to fix these problems, right? The problems are not going to go away, because the challenge with AI is that it's a garbage in, garbage out situation. So if the data you're using to train your AI is low quality, the answers coming out of the AI will be low quality. It'll reflect the data. It's as simple as that. So we've got this, just a common challenge. Another challenge, and this is particularly frustrating for the business side of the house and the management side, is that we could run into never-ending edge cases. And what I mean by that is, as you're exploring the problem domain, as you're doing the work to build the AI or build the robot, whatever it is that you're building, you're just running into problems, and you realize you discover. So, for example, I was involved with a robotics firm, and they were building things that would grab, it was a picking robot, so it would grab cans off a shelf or boxes off a shelf or fresh fruit off a shelf. And what would happen is, it would, pick up a can, that'd be okay. But then it would go to pick up a collection of grapes and would crush the grapes, and you've got the beginnings of wine. Well, that's a problem. And because people don't like crushed grapes. And so the thing is, that was a 3-month problem. They didn't know about the grape problem or the banana problem or whatever piece of fruit it was. And picking up bananas is different than picking up grapes, of course, right? So there's another edge case. Picking up big cans is different than picking up soup cans and all good sort of stuff. So what happens is, you're running these edge cases, and that's a 2 to 3 month problem to solve. Maybe it's 2 to 3 week problem, but it's a problem. It's a indeterminate size. So you do an estimate, and then suddenly your schedule blows out. So you've got because you're dealing with with significant complexity and potential chaos, you have a reasonably unpredictable timeline as a result, at least from a classic project management point of view. That tends to blow people's minds. Then, of course, deployment. Are your stakeholders even ready to have this AI or these robots forced upon them? When it's up and running in production, you could have biased usage. So you could build a really good AI that's really solid, and then people use it to do evil things. Maybe on purpose, maybe inadvertently, but things happen. You release in production, it's not viable. You start getting learnings back. You start getting new data from the usage, and you got a couple problems there. One is called model drift, which is a misnomer. It's really reality drift. So the problem is I train the model on my data today, deploy it in production, but then my environment changes, right? My competition does things. My users want new things. They do things in a different way now. Business processes change. Political crap happens. Whatever, right? The environment changes. So now reality is different than what my model was trained on. So we don't blame reality, of course. That would be unfair. We blame the model. So the model has drifted away from reality, or whereas actually, no, the model stayed and the reality drifted. But anyways, there's a delta now. So we got to retrain the model, which is why this is not really a project. It's this ongoing product life cycle. And then function creep. So people start using the AIs, or start using the robotics, or start using the surveillance system for different purposes than what they were meant for. And this is a classic problem in surveillance land. I'm not going to go into some horrific details, but anyways, it's a problem. A very good book to get a handle on these sorts of problems, particularly bias and inappropriate usage, is a book called Weapons of Math Destruction. The author just isn't coming to me off the top of my head. Hopefully I remember. Kathy O'Neill. Fantastic book. So I highly suggest, if you're going into AI for the first time, start by reading that book. Particularly if you're on the business side of the house or a manager, you need to understand the implications of what you're doing. And because that book is full of stories of people who did not understand what was going on, who were doing things to their best intentions, and lots of people got harmed for very different reasons that was not predictable, probably not predictable at the upfront. So be very, very aware. So I've talked about data quality a fair bit. So what are the implications there is a valid question. So as I said earlier, it really is time to pay the data piper. There's no other choice. It's garbage in, garbage out when it comes to AI. So what are some of the common DQ problems you're going to run into? I've talked about these earlier. You've got biased data. You've got insufficient data. So maybe you've got to create artificial data. You've got missing data values, inconsistent data, all the classic, the data just talk to your data warehousing team. They can give you a long list of the garbage they deal with on a regular basis. This is just a brief summary of it, but there are a few unique data quality problems in AI, one of which is called data poisoning. So when you're training AIs or you're using a model that's been pre-trained, like a foundation model, and now you're putting your detailed stuff on top of that. If that model has been trained in, say, internet-based data, then some of the internet-based data is not accurate, as we know. Some of that data has been generated by other AI, so that's not accurate as well. So these generative AI models like ChatGPT or all these things that are generating images, generative AI, the purpose of that is to make stuff up. Period. That's all it does. 100% of the time, it's made up stuff. Now, people talk about, well, it's hallucinating. Yeah, the AI is hallucinating 100% of the time. It's just making things up. Some of those hallucinations are what you agree with. They're fairly accurate, so it's a good hallucination. That must be a good answer. Sometimes it's obviously wrong, so it's a bad hallucination. But it's all hallucinations. It's all made up stuff. So when somebody uses ChatGPT to help them write a blog, or to write the entire blog or the entire book, and then they post it online, and then another AI is trained on this hallucinated information, well, it's been poisoned, let alone the people who are purposely posting nonsense right now for various reasons. That's also messing up these AIs. So better be aware of that. And we talked about data drift and other good stuff. So anyways, and ownership. Do you even own this data? So right now, there is one heck of a IP discussion going on, because a lot of these AIs have been trained on copyrighted data, copyrighted information. There's some very interesting court cases, which I think the tech bros are going to lose. So anyways, be very careful. Because if you're, so for example, it's very easy to build a chatbot. I could build, like, literally this afternoon, I could build an insurance chatbot on top of ChatGPT 4 and roll that, not that I want to do that, but I could roll that out tomorrow, this evening. But gotta remember, a lot of that stuff coming out of that chatbot is based on copyrighted information, which you don't own and you probably shouldn't be using. So anyways, be aware. I think the IP issues are going to really come around to bite a lot of us in the next couple of years. Might be a little slower in the States, but certainly in other parts of the world, it's might be this year. So anyways, be careful. So some data, some of the data quality techniques. This is this is just the tip of the iceberg. But the couple main points here. First, you've got options, which is good. So those of you familiar with DA know that you've got options. There's no such thing as best practices. Any given practice, any given approach works well in some situations and not in others. So there's advantages and disadvantages behind each of these strategies. So depending on your context, you need to pick the right strategies for your situation. This is actually something that certainly DA took a shot at. It took some of these techniques a few years ago. In the Agile data space, I'm going into detail because there's data stewards, for example. It's anyways, all good stuff. So just be aware of that. So something to look at. So use the right use the right technique for the job at hand is what the message is here. So another thing that you should be considering, I'm going to wrap up in a few minutes, but just to sort of get towards the end, some ethical considerations. Now, I'm not in a position to lay down the law regarding ethics. But my advice is you need to have, so your ethics and your organization's ethics are context sensitive. So your company will have a certain way of working, a certain set of values, a certain set of ethics that reflect your situation. Another company, another organization will have a different set, and there'll be significant overlap. So insurance company one will have a very, like American Insurance Company one will have a very similar set of ethics to an American Insurance Company two, but it will vary compared with French Insurance Company one. It will vary again with Canadian Insurance Company one because they face different contexts and they have different sets of values, and that's okay. So be aware of that. But here's a good list of things that I would be I'm generally concerned about when I'm working with organizations. So first of all, safety. Is there a potential for harming people? And it might not be physical harm. It could be financial harm or mental harm or just cultural harm. So be very aware of that. And this is why that book, Weapons of Mass Destruction, is a very interesting, important read for you. And then there's the consideration of human dignity. So is your AI taking valuable work or interesting work away from people? Are you treating your customers fairly in a dignified manner? Are you taking multicultural considerations into account? Because the way that you interact with Canadian men is very different than the way you would interact with French women, for example. And are you taking that? Do your systems reflect that? And all this sort of stuff. Does it take societal values into account? These are critical things because the challenge with AI is that you're working at scale and you're working at internet speed. You're working at AI speed or computer speed now. So things can go very well for you very quickly, and they can go spectacularly poorly for you very quickly as well at scale. So I'll share a horror story or two in a few minutes. Fairness. Are you dealing? Do you understand the bias in your data? Do you understand the bias in your model? How fair is your model? How fair is it? And there's the obvious issues, which are very difficult, such as gender and race and culture. But there could also be there will be other fairness issues as well that are specific to your domain or the subdomain that you're working in. And are you monitoring for that? Are you measuring for that? Are you even aware? And so this gets back to diversity on your team is absolutely critical for this. And are you accountable? So, for example, I wrote a blog a couple months ago now about self-driving cars, and the primary thing that's hanging them up right now is accountability. So, when the car kills somebody, and that has happened, and it will happen again, who do you sue? Who do you hold accountable for that? Right. So it's interesting even though there's very good stats showing that in most situations the self-driving cars are better than the human driven cars right now. The big problem is the accountability issue, and because the cars, things are going to happen. So, anyways, and how do you explain? So a big challenge with the AIs is sometimes it does appear to be magic going on under the covers, because when the AIs are training themselves and they create these models that because it's just mathematical formulas and all that good stuff going on. How do you actually things happen and you don't have no idea? So, for example, I guess it was Google was training a translation system a few years ago, and it picked up a language that it wasn't trained on. So, picked up Farsi, or I can't remember what language it was, so don't quote me on this. But it learned Farsi somehow, if that was the language that it picked up, and it wasn't trained for Farsi. Yet it figured it out anyways. So things happen. I'm sure there's a few AIs that can speak fluent Klingon, having never seen the original Shakespeare written in Klingon. But anyways, for the Star Trek fans out there, do you know where your data came from? Do you know how it was produced? What's the provenance of that data? Those are very interesting questions. Can you trust the data that you're buying or that you're borrowing? when you train it from other data sources that might not be your own. Very, very important things to take into consideration. And how trustworthy are your models? Can you explain how they made a decision? So if I'm building a system that is making decisions as to whether or not you get a mortgage, and my system decides, no, you don't get a mortgage, can we justify that? How did we come to that decision? Because the answer is probably not going to be acceptable that, oh, the AI says that, no, you're not worthy of getting a mortgage. You might not like that. And you might have, your lawyers might have an issue with that as well. So anyways, we've got to be able to explain, to have trustworthiness, we need to be able to explain our models. And it's interesting, if you look at the European AI Act, it talks about all these sorts of considerations. So they're starting, at least the EU is starting to put these things into law. And we'll see other jurisdictions. Canada is doing this, where I live is doing something very similar. So, and if you look at the way the regulation world works, the EU or California in some cases tends to lead the pack, and then everybody borrows ideas, almost copies and pastes the ideas from whatever the Europeans do. So put a slightly different spin on things, but that's the way it works out. So anyways, that's probably coming your way. So just to wrap up here, so some business implications of AI. What are the things you should be eagerly looking forward to and eagerly afraid of? So there's a lot of opportunity for improving your business processes, for providing better customer service, for augmenting your people. I hope that's what your focus is on, is augmenting the work of people to free them up to do more interesting things rather than simply replace them. But there's also some very significant risks of AI. So one of them is reputational risk, because things are working at computer speed. So a few years ago, Microsoft released a chatbot out into the wild called Tao. And this happened, I can't remember, 4 or 5 years ago now, I think. And within 19 hours, they had to pull the plug because it became a raving racist. Another organization just recently also ran into a similar problem too, where they released a new AI, and it soon started listing the people that needed to be killed. So because these AIs learn, right, and they learn very quickly, and so there's some significant reputational risk there. What was interesting was I was at a developer conference just last week, and I sat in on several AI talks, and 2 speakers talked about Tao. So Microsoft still has years later still has reputational risk because it's a great story. But the really good thing is that they monitored what was going on. They very quickly realized they were in trouble and quickly pulled the plug as soon as they could. They yanked this thing out of production because they knew they were in trouble, and they did the right thing. So kudos to Microsoft for doing that. But imagine your organization and you don't have adequate measures in place. You don't have, maybe your DevOps environment isn't quite what it needs to be. Maybe you're not as technically savvy as Microsoft. What are the odds, right? And you roll something out into production, and you've got an AI out there, and it's making bad loans, or it's not letting people get the right loans, or it's preventing people from getting access to important functionality. And it takes you weeks or months to detect that, if you detect it at all. Like your detection mechanism might be lawyers show up at your door, and suddenly you've got a problem. So once again, I'll plug Kathy O'Neill's book, Weapons of Mass Destruction. So anyways, a lot of great benefits, a lot of potential benefits, a lot of potential risks as well. So go in eyes wide open. So some success and failure factors, and this is basically just a repetition of the slide that we saw earlier, except this is now at the initiative level rather than the organizational level. So whatever it is that you're doing with the AI, are your expectations realistic? Do you have a handle on the ethical issues that you're dealing with? Because you are dealing with ethical issues, like it or not. This is a harsh question, but are your leaders capable? Do they understand what's going on? Do they understand the exploratory nature of AI development? Are they smart enough to know that maybe you've got some data problems, and maybe you're going to run into edge cases that you're just going to have to deal with. Is your data ready? Chances are exceptionally good. The answer is no. So perhaps a fair question: are you willing to do what you need to do to get it ready, to pay down that technical debt? Are you actually building a diverse cross-disciplinary team of dedicated staff? So they should be on this effort 100% of the time. None of this 50% here, 50% there, and 50% on this third project nonsense. Are they 100% dedicated to the team? Do they have the skills to get the job done? It's brutally hard right now to find AI skilled people, and because a lot of it's data science stuff, and there's not a lot of data scientists out there. From a discipline Agile point of view, have you defined your way of working for this initiative? Do you actually understand as an overall group how you're going to work together, and how, what needs to be done, and how you're going to do it, and what you should be looking out for, what your risks are, how you're going to deal with those risks, and so on. So easier said than done in many cases. So anyways, a lot of things you want to be careful about. So hopefully this was useful to you. For those of you who might be interested in having this presented to your PMI chapter, your some data user group, or even for organization, feel free to reach out. I'm happy to do this again. So let's go to questions.
Yeah, and I also, Scott's made the slides available along with some additional content. So I popped a link to Scott's website that has some good content on it. And I think there were at least one or two questions. Yeah, so Vicky's got one.
Okay, is that the one about bias data?
Yes.
Okay, so Vicky asks, can you provide an example of bias data that you've encountered, and how you explain the issue to your stakeholders? Yeah, so in an insurance, I can't tell you who this was, but in an insurance setting, it was fairly clear that certain groups of people, based on where they lived, actually, or based on their zip code, but so where they live, were being biased against. So you live in a bad part of town, we're not going to insure you, was the basically the process that was going on. And of course, none of this was written down. You can't really, it's certainly from a legal point of view, you don't want to write it down, but this was the effect of what was happening. And they had good excuses for why this was happening. Well, they don't have assets, they don't have this, they don't have that, blah, 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 blah. Yes, but so anyways, so we worked through it, and we said, well, is this fair? Is this an underserved community? Look what's happening here. This is even though you say, well, this is a bad zip code for whatever reason, the fact is it's a fairly homogenous group of people that, were we to hop in our car and go to that zip code, we could pretty quickly identify what group of people you're biased against on this. What do you want to do about that? So anyways, and these are hard discussions. I was involved with another team where I can't remember what the exact issue was, but somebody with a very different background than mine piped up one day, and she said, well, wait a minute, what about this type of group of people? And it was like deer caught in heads, like, I don't know. And none of us had considered that. So we started looking into it. So it wasn't really, we discovered it in the data, but what happened was we discovered a potential bias that once we started looking into it, said, "Ooh, yeah, we're probably not treating this group fairly. What can we do about that?" In this case, it was more of a change the business process. But as well, what we ended up doing as well was we had to create some synthetic data to basically better have more representatives of that type of group in the data. So that way, when we trained the AI on the data, there was enough information there to train the AI of here's what should, the AI could figure out, okay, here's what I should do in these situations. Because the problem with edge case people, I guess you would say, is that when there's like only 2 or 3 people in this situation, in this area, perhaps, or doing business with us in this way, and there's 500 people not like that, the 2 or 3 people that are like this, 500 people that are not like that, the AI will optimize for the 500 people, and the 3 or 4 people in this important edge case will just get, they'll become a round off error, and that's not right. So this is the challenge there. So and that's hard to find. You've got to be really thinking through what's going on and having these conversations and be actively aware of the potential for this. So hence the diversity is a very good thing.
All right. I think the only other question I saw was from Steve, which was something I hadn't thought of and I should have. So going forward, I will have meeting summary notes feature turned on and make them available right after we get done with these streams. So yeah, thanks for asking that question. And I should have already been thinking about that. So I will for future ones. Don't see any other questions.
So here we are. So here aren't we spoiled, right? Because a couple years ago, we would have, if meeting notes were important, we would have had somebody or somebody's madly taking notes as we were, talking, or more realistically, going through the recording and spend, because I think it's like 6 to 8 hours per hour of recording that it takes to truly transcribe. And here we are. Why didn't we just turn on the AI, or why didn't we turn on the AI and pump this out in Klingon, or pump this out in Spanish, or whatever appropriate language would have been. And these are just these are built-in features in many, like PowerPoint now. You can choose the language that you want to automatically translate in, and that's just pure AI.
Yeah, what I really want, Scott, is I want you to deliver the presentation in Klingon, and then have the AI translate it back into English and other languages.
Okay, well, yeah. I'll get on that.
Yeah. So if there's any other questions, whether you're watching this live or if you're watching it on replay, just post on LinkedIn. We'll take a look at it, as well as take a look at the link to the slides on Scott's website. And yeah, thanks once again, Scott, for presenting today, and thanks everybody for being in attendance. Scott, any last parting thoughts, or can you speak Klingon? Can you give a parting?
Kapla. You can talk.
Excellent.
Yeah, pretty good. Yeah, no, yeah. So drop by agiledata.org or scottambler.com. A lot of great AI and data stuff on those sites.
Yeah, excellent. Thanks everyone. We'll see you on the next stream.